This is our setup for experiment number 3, stop that gamma. And here we have our gamma source set up 8 centimeters away from our detector. And at this distance, we were able to measure a radiation level of 0.7 counts per minute on the 10 times 10 scale. And then moving it back to 16 centimeters away from the target, we were able to measure 0.3 counts per minute on the times 10 scale. And from here, the radiation will start to drop off once we move our source from 16 centimeters to 24 centimeters. So after resetting the counter, we switch down the scaling from times 10 to the 1 scale. And at 24 centimeters away from the target, we measured a radiation level of 0.9 counts per minute. And then from here, we're able to move it back to 32 centimeters. And after resetting it, we're able to read a level of 0.5 on the 1 scale. And again, once we move it back from 32 to 48 centimeters, we have to lower the scaling because the radiation has dropped off. And from this distance, we're able to read 1.9 counts per minute on the 0.1 scale. After gathering our first set of data, we were able to go back and complete 2 more trials to get a full data set. And from here, we're going to compare these numbers to the inverse square law and see how well they hold up. To compare our measured data against the inverse square law, we want to create a graph. So we're going to average all of our data and use that to form a line on our graph. And then we're also going to apply the inverse square law to create a prediction of how much radiation we expect at each distance. And this is going to be the second line on our graph. So with these numbers shown on screen, we're able to create a graph that looks something like this. So all the calculations that we just did allow us to make this graph of our measured data versus our predicted data that we found using the R-squared law. So compare the R-squared law to the measured data and notice the differences in trends. And using this graph, you'll be able to answer analysis questions at the bottom of our experiment and hopefully think some more about gamma radiation and how it gets affected with distance.